And finally, the Pythagorean theorem. This is usually the one we have the strongest memory of. It tells us that for a triangle that it has a right angle, so for a right angle triangle, in which the hypotenuse is labeled as c squared is equal to a squared plus b squared. In other words, the square of the hypotenuse is equal to the sum of the squares of the other two sides. There's one thing I want to point out here. If this is not how the triangle is labeled, then that's not necessarily the correct way to express the Pythagorean theorem. If, for example, we had labeled the hypotenuse as a and the other two sides as b and c, we would now want to make sure we express the Pythagorean theorem as a squared is equal to b squared plus c squared, ensuring that the hypotenuse is the one that's equal to the sum of the squares of the other two sides. Yes, most often we do label the hypotenuse as c, but what we want to do is avoid simply memorizing a formula and being clear that the Pythagorean theorem always has the hypotenuse equal to the sum of the square of the other two sides, regardless of what letter we have given to the hypotenuse. And here are two problems. We're asked to find the third side of the triangle and given two different questions. In this case, again, we have labeled the triangle so that C is the hypotenuse. So on the left-hand side, we're told that A is equal to 2.48. So I'll write that in here, 2.48. That's in meters. B is 1.45 meters. So for the question on the left, we're asked to find C. And because the hypotenuse is labeled as c, we write c squared is equal to a squared plus b squared. Now, I'm not interested in the value of c squared. I want to know what the value of c by itself is. So what I do is I take the square root of the left side and therefore the square root of the right side. The square root of c squared, we should remember this from algebraic operations, is just c. Right? The square root of anything squared is just that thing itself, the base. So c is equal to the square root of a squared plus b squared. It's often handy for us to rearrange the equation first and then start substituting in numbers. So a and b we do know, so we'll substitute the numbers in at this point. We have 2.48 and that's squared. And then we'll add side b, which is 1.45, also squared. So in this case, do we really need those brackets? No, because positive 2.48 squared is going to work out for us. In other words, if I have 2.48 squared or in brackets 2.48 squared, in both situations my answer will be positive. So while the brackets are more correct, we won't get the wrong answer here. Remember that we would have had the wrong answer if we had negative 2.48 and negative 2.48, where the answer here would be positive. This would give us a positive answer, and this one here would be negative. In any case, we're talking about side lengths here, so that's why, for this instance, I'm not too worried about whether or not you've included brackets. Now, I do recommend that you punch this into your calculator all at once, rather than writing down intermediate steps or intermediate values. If you are going to write down intermediate values, be very careful that you write down sufficient numbers of decimal places, more than you're going to need in the final answer. And I'm going to round this one to 2 decimal places, and that does give me 2.87 meters squared. Try this a couple different ways. Do make sure that you're getting the same digits in this 100th decimal place. For this next question, we're given sides A and C, so we'll need to find side B. It's mapped onto the same triangle. Here we're not given units, so our answer won't have units either. We're told that side A is 175 units long and side C is 551. We'll write our formula first. C squared is equal to A squared plus B squared. All right, in this case, we're being asked to solve for B though. So we have a little bit of algebra to do before we drop in our values. To solve for B, we need to isolate the term that B is in. So we'll isolate the B squared. We'll do that by subtracting A squared from both sides. I'll also rewrite it so that B squared is on the left-hand side. But think of it this way, if I subtract A squared from both sides, that'll leave us on the left-hand side here with C squared minus A squared. Check for yourself that you're comfortable with this. All right, I'm not interested in b squared. I'd like to know what b is on its own, so I'll take the square root of the left side and the right side. That leaves me with b is equal to the square root of c squared minus a squared. Now I'm ready to substitute in our values. So it's the square root of c squared, and that gives us 551 squared. Again, whether or not I include brackets, I'll get the same result. And then I'll subtract 175 squared. If I were to include brackets, where would they go? Certainly not including the negative. It's simply the length of 175 that's squared here. So just for extreme clarity, let me throw in those brackets. Again, try this in one go. And to the nearest whole number, we get 5, 2, 2. Let's check that our values make sense. Because the hypotenuse is across from the largest angle, you can't have an angle larger than 90 degrees and still have it be a right angle triangle. The hypotenuse should be the longest side. So in the case of the second question, we determined that side B had a length of 5, 2, 2. That leaves the hypotenuse with the longest side. It's true, this triangle isn't to scale, so do be careful with that. If I look at C, what we found on the left-hand side, we found that the value of C was 2.87, which was larger than either 1.45 or 2.48. So I don't know that I have exactly the right answer, but it is certainly plausible. The fact that it is the longest of the three sides is what leads me to that conclusion.